Hello, everyone. Thank you very much for attending this session. I'm Gao Lei from IBM. In the following time, my colleague Wang Jin and I will present AI use case. It's about the market event impact determination by the sentiment and emotion analysis from the news. First, we will briefly introduce some background about how the AI is applied in the financial service industry. Then we will bring the solution for the use case with the detailed technical points. And last, we will use the solution to solve problems about how the daily news impact the oral press. Okay, let's start. First, let's have a look at how AI is deeply integrated with the financial service industry. Nowadays, more and more financial service organizations realize they have a good start with the application of AI. Because they have large data sets, they also have the requirement to analyze the data sets for any valuable insights. And they also have the appearance to use the analytic tools. So using the components of machine learning, the natural language processing, and the cognitive computing, AI can be applied in many parts of valuable chains in the financial service industry, such as the payment service to the daily banking. For example, machine learning can help on identifying the unusual patterns of transactions, which can indicate the fraud. So the financial crime detection can be hugely benefited from the advancement of AI. Then the natural language understanding and the natural language processing is starting to have a big impact in the document-heavy financial services. For example, the text understanding and the chat box. And third, the cognitive computing. Cognitive computing is good at the automating the financial decisions. This can help people to achieve a kind of algorithmical trading. Then next. This is a report published by World Economic Forum 2015. As a result of 15 months research and survey across many different financial service organizations, the innovation and usage in machine-readable news, big data, AI, and machine learning have the potential to reform the financial service industry. It could shift the industry from the post-trade historical analysis to the pre-trade predictive analysis. Let's have a close look at the three major trends. First, machine-readable news is to assess the news feeds through the algorithms in real time without any human explanation. And then big data focus on assessing the massive and extensive real-time data sets to uncover the predictive insights on market movements. Then and last, the AI and the machine learning. AI and the machine learning helps to improve the overall accuracy, consistency, and the speed of the trading through the automation and self-learning. So from the above description, we can see that AI and the machine learning take a more and more important role in the financial service industry. Okay, this is a use case we are talking about. This requirement is come from a financial service organization. It's about using the natural language processing against the news so as to add a additional dimension to make data, to market data. Then, based on this merged data, driving the machine learning algorithms to determine the potential for the market impact. Well, to understand the requirement, we will see several key technical points. First is about the social settlement analysis by the natural language processing and the text mining. And another is about the automating the process for real-time analysis. Moreover, considering the massive data sets from the news, we need to leverage Spark for the big data operation and analysis. Here is a solution template with the key technicals. It covers both the open source and the business applications. We can apply the process to any specific problems with the business understanding. For example, to work with the SS feeds, we can use the feeds parser, an open source package, to perform for the SS feeding parsing. Then leverage IBM Waston service to perform the emotion and sentiment analysis. Then with the data, Spark Circle can help us to wash, to ingest, and to aggregate the data. Because the emotion sentiment analysis results from the daily are accumulated day by day. So we need to keep them into the distributed database. Here we can use the HBase or the IBM DB2 warehouse. Next, then we can combine our sentiment and emotion analysis result, the data, with the market data for the further analysis. The exploration data and the predictive model can use the Spark MLlib, scikit-learn, or SPSS models. And last, to show the insights from the model, we can leverage either open source Python libraries or SPSS model viewer. The key point in the process is the natural language understanding and the Spark data operations and the machine learning model for the analysis. First, let's have a quick look at the Waston API services. Let's show all the Waston API services in the IBM cloud. IBM Waston AI services provides a suite of useful and powerful APIs, which covers the service for text, picture recognition, natural language understanding, and the speech-text translation, as well as other useful tools. Meanwhile, and more important, Waston also provides a unified analytic platform named Waston Studio, which is a suite of tools for data scientists, application developers, and the subject matter expert to work together with the data and create an end-to-end solution. User can just create and use this API from the IBM cloud. The link is below in this page. IBM Cloud is a cloud platform as a service provided by IBM. Okay. Here shows all the service regarding Waston AI and on the IBM Cloud. And in this solution, we will use the natural language understanding as the sentiment and emotion analysis engine, and Waston Studio as the analytics platform. Okay, first, just as I said, we will use the Waston natural language understanding as the sentiment and emotion analysis engine, Here is a brief introduction about that. This service provides powerful insights to analyze semantic features for given text input according some keywords. It can analyze categories, concepts, emotions, sentiments, up to 9 features. It supports a variety of country language, and the input data source can be plain text, can be the HTML or a public URL. It supports several programming languages to make it easy to integrate it with numerous applications. Okay, in the next 3 pages, show the all the 9 features of Waston natural language understanding. I will not introduce them one by one in details. Here we can just to say how the emotion and the sentiment analysis use. Okay, in this page we can see in the third one is about emotion. Emotion is to analyze the emotion convert by the specific keywords from the given content. It can detect 5 emotions: joy, sad, anger, fear, and disgust. Meanwhile, with the analysis result, we'll give a score value from 0 to 1 to measure the emotion degree. So, for example, we can see the input. If we input the I love apples, but I hate oranges. The keywords we select apples and oranges, so the response will return us apple is joy, and with the score 0.85. The similar is with orange, but the emotion is anger. Okay, this is another 3 features for Waston natural language understanding. Okay, the last 3. The third one is about the sentiment. Sentiment analysis is similar with the emotion. The result will show the sentiment tones for the specific keywords for the given content, either the positive or negative with the score value. For example, if the text is "Thank you and have a nice day," the response will return us the positive sentiment with a score value of 0.91. Okay, just we introduced the natural language understanding from Waston. From this page, we will see some quick look at the Waston Studio. Waston Studio is a analytic platform provided by IBM. It provides a suite of tools for data scientists, application developers, and experts to work together with the data, and then use the built-in analytic tools to create an end-to-end solution with the big data. It integrated multiple popular analytics runtime, such as Spark, and the kinds of analytic tools. Okay, this picture shows the analytic tools and the analytic runtime of Waston Studio. From this page, we can see that several analysis tools are supported in the upper level, such as Jupyter Notebook, RStudio, and SPSS modular. Waston Studio provides both the machine learning runtime and the deep learning runtime. The Spark is a very important runtime in the form of the machine learning. In the low-level infrastructure, Waston Studio also provides GPU to accelerate the performance for big data analysis. Okay, next I will introduce some background about SPSS. SPSS offers a vast library of the machine learning product family. The traditional product family for SPSS include the SPSS statics, modular, collaboration, and deployment service, and the analytic server. Besides these products, SPSS algorithms are also a very important algorithm assets. Now, the algorithms have started to serve more and more IBM products for the big data. Before 2010, SPSS mainly provide the products and solutions for desktop users. Then when Hadoop and Spark become more and more popular, SPSS started to implement the distributed algorithms. Okay, this page just show the SPSS algorithms on the Spark. From 2010 to 2015, we designed and implemented 20 plus algorithms under the Hadoop MapReduce framework. They are for distributed computation and also for the distributed data. When Spark become more and more popular and IBM start to invest the Spark as its big data analytic runtime, we add the Scala wrapper for this Java Hadoop algorithms to provide the standard Spark machine learning APIs as the Spark MLab. So these Java algorithms can be used in Spark runtime as well. We also implemented some Scala algorithms by the Spark RDD, low-level RDD operation directly. Okay, we just introduced the related technicals, the Waston natural language understanding API, the Waston Studio, and the SPSS algorithms. So then we will see an example about oil price influenced by the news. We will see how to use the solution to solve to detect the relationship between the oil price and the newswire. The target of this example is just to discover the impact of news on oil price and try to build a predictive model to describe the relationship between the oil price and the news. The news are from some different RSS channels. We can see that we can select as channels from the business news, the company news, and some general RSS feeds. The keyword categories, we can select the type of areas and also some influential agencies and some influential country, influential person. The oil price, we can use the New York crude oil future and all the E-mini SP 500 future. Okay, this picture shows we applied the solution to these specific problems. We implement the process in the Jupyter Notebook in the Waston Studio and leverage the Spark as the runtime. In Waston Studio, we can schedule the RSS feeds, passing Waston settlement emotion analysis, Spark circuit for the data collection and aggregation daily, and write the daily analysis data into the IBM DB2 warehouse. Once we accumulate the emotion and settlement analysis result more and more, we can combine the data with the oil price from the Quado then we can, Quadro provides a series of open APIs to get the historical oral price. Then we can run algorithms to analyze the relationship between the news emotion settlement with the oral price. Here, we select to use the SPSS algorithms, the time series algorithms from SPSS. Then, in the following slides, we will show some code fragment about how to use the Jupyter Notebook for the analysis. This picture shows how to generate the settlement and the emotion score. As a result, shown in the right, we can see that we daily to accumulate the settlement and emotion analysis result with the keywords, also with the news link from different from different RSS feeds on each day. Then in this page, we combine the settlement and emotion score data together with the oral price data from the Quadro as one table in the right. In this process, we need the help from Spark Circle to aggregate the settlement emotion data to daily first, and then merge with the oral price by aligning the time. Then next, we can use SPSS time series RIMA model on the Spark to build the relationship between the oral price and the settlement emotion analysis score. We use the daily open oral price as a target time series and use the settlement emotion score values as a predictor time series. The SPSS algorithms under Spark also have a similar API as the Spark MLab. To build the model, we use the fit, and to score the model, we use the transform. It's similar. Yeah. Okay, this is the last one. In this page, we create the insights with the plots. From the figure 1, show that the comparison of the fitting oral price against the open price or open oral price. We can see that the fitting values meet the open oral price well, and the trend are almost the same. And in the figure 2, it's the last 100 selected time series points. Although there are some deviations between the fitting values and the real open oral price value, but the trend are still almost the same. From figure 2, we can also see there are several steps for the predictive, for the future oral price predictive, which can be a reference for the future oral trend. Okay, that's all for today's session. The oral price prediction is just an example of this solution. When meeting the specific business problems, the customer can select the proper models, proper machine learning models for their proper specific requirements. That's all. Thank you very much.
Thank you very much, Lei. And we have about 5 minutes for questions, and there's a break after this as well. Anybody?
No. Regarding about your RSS news, I suppose, I don't know whether it's true or not, like maybe the more data is the better in that sense. But I suppose what I'm wondering is in terms from the internet, then you've got news and whether the news are credible or and so forth, whether it's true or false and that kind of stuff. And do you think these kind of issues may have an impact on the analysis afterwards, or whether you need to have some kind of prejudgment of what kind of RSS feeds that you put it into your machine learning model in order to maybe make the prediction better or so forth in that sense?
Yes, these are very good questions. So we know that different RSS, different news have the different attitude for the specific business problem. Yes, it's right. So when we select the RSS feeds, so we need to judge which RSS feeds we need to select. We think that in this solution, when we do it, we select many kinds of RSS feeds from different categories, from different business, from different companies, then mix them together as a settlement and emotion analysis base. So because we use the Waston natural language understanding, with the result will return us the score value. We average all the score values to mix the impact of the attitude from different news to the mixed. Yeah.
Two short questions. So first question would be, do you have any metrics for for performance of this model? How you measure the performance? Because I mean the chart looks good, but also some numbers would be nice to see. And the second question is, do you do intraday analysis of I mean the intraday prices, or you use only the closing opening prices? And then if there's a second option, then how you treat the news? So if the news are from the same day or they are from the day before, because if they are from the same day, for example, and you train that with the closing price, then it means that maybe the event occurs during the day and the news are actually after the event. So that's the question.
Okay, thank you. Regarding the performance, because when we create this solution, it's just a requirement from the customer for POC. So we just use this oil price impact by the news feeds as an example. So the data is not that big. And from our appearance, we select almost 20 or 30 RSS feeds for this. And when select the keywords to analysis, we found that not all the news feeds can be include our keywords. So after that, we only get limited records, which is not too big. So we don't meet the performance problems during our analysis. Yeah. Sorry, I'm not quite understand your second question.
If you do when you try to match the unstructured data like this news data with the time series data,
yeah.
Do you also so the source, if the source of this data is the intraday values, like for example like every minute, or you check the price, or it's like the closing price, so it's like the daily time series.
Oh, okay.
And then how you treat the, how you match the news with that data. So if they are from the same day, where you, for example, compare the closing price, or are they like from the day before, or how you match that? Because sometimes the event may occur during the day, and when you take the closing price, and then you take the news from the same day, maybe the news is from, it's actually not predicting that, but it just, telling the story that, okay, the price of the oil like fell down, and then there's a negative sentiment, but it's it's not like the causation, but the effect, actually.
Okay, thank you for the explanation. Yes, in the ISS phase, every day there will be, almost every day there will be some phase from the ISS. It includes the data, also includes the time. Here, in this example, we just the time series we use the day as a time period. So, but from the ISS phase, we will get many feeds from different news link from different time of a day. So we, just as I said, we first aggregation the score values, the sentiment and emotion score values to day as a period. Then we got from Quado also from as a day period. Then combine them together. But to specific problems, you can use the minute or the hour as a time period. That's okay.